Welcome to MRL. In this learning session, we'll be learning a very important operation in algebra, and that is factorization. Now, factorization is a process of expressing a number as a product of numbers. Factorization is a process of expressing an algebraic expression as a product of two or more algebraic expressions. So please remember that factorization is a process of expressing an algebraic expression as a product of two or more algebraic expressions. A very, very important operation. We'll be learning why. Now, the methods of factorization. There are different methods of factorization, and they are taking HCF common, grouping and taking HCF common, regrouping and taking HCF common, identity method, middle term splitting method, and factors theorem method. Now let us understand it. And the identity which we are using here is x plus a into x plus b, that is x square plus a plus b x plus ab, and that is used in the splitting method. Now let us learn these methods one by one. Now the first method is the taking HCF common. Now we have algebraic expression here 12a square b and 15ab square. Now we have algebraic expression 12a square b and 15ab square. Now the factors which are common in these two, let us see what are the factors here. So let us take the constants first, 12 and 15. The HCF of 12 and 15 is 3. So 3 is common. Then the HCF of a square and a is a, and a is common. HCF of b and b square is b is common. Take the product of the common terms, 3 into a into b, so 3ab is the HCF of both. So take 3ab outside and remaining terms you put in the bracket. Now if you multiply 3ab into 4a, 3 into 4 is 12, a into a is a square and b, then multiply 3ab into 5b, we get 3 into 5 is 15, a is a and b into b square, and therefore it is 100% a correct factorization. Now here we had an algebraic expression and we have expressed it as a product of two algebraic expressions, that is 3ab and 4a plus 5b, and that is what is called as factorization, and the method adopted here is the taking HCF common. Remember that. Now let us take one more example. Now we want to factorize this, that is 20 L square m plus 30 ALM. So first find the HCF of 20 and 30, it is 10. Okay, it is 10. Find the HCF of L square and L square and L is L, and HCF of M and M is M, and therefore the product is 10 LM. Take 10 LM outside and the remaining factors put it in the bracket here. Now let us see, it is 10 LM in the bracket 2L plus 3A. So 10 LM into 2L, 10 into 2 is 20, L into L is L square and M as it is, then 10 into 3 is 30, L a is 3a is here LM, and therefore we have expressed this expression as a product of two expressions, and that is a factorization by taking HCF common. So in factorization by taking HCF common, take tell LM outside, and which are common to both the algebraic terms here, and the remaining terms we put in the bracket. So that is the method. Now the second method of factorization is grouping and taking HCF common. Now we have four terms here. Earlier we had two terms, here we have four terms. When we have four terms, then we can group them and take HCF common. Now let us group them first. X square plus xy and 8x plus 8y, and the grouping is done by inspection, so that we get HCF common to the two terms here and the two terms here. So now in the common, that is HCF of x square plus xy is x, because x square is there, x is there, so we can take x outside. So x into x is x square, x plus into plus is plus, x into y is xy. So x is outside, and in the bracket we get x plus y. So we have expressed as a product of two algebraic expressions here. And now here also take 8 common, x plus y. Now in these two, what is common? X plus y is common. So take x plus y outside and put x plus 8 in the bracket. So the method is first group them, pair them, and then take HCF common, and again take HCF common. That means two times we are taking HCF common. Again, remember, ultimately the important step is taking HCF common, and that is two times, here and here. Now therefore grouping and taking HCF common is again another method which we have understood here. Now regrouping and taking HCF common. Now here we have an algebraic expression given to us, 6xy minus 4y plus 6 minus 9x. Now by inspection we understand that we have to be regrouped. Therefore I have kept 6xy here as it is, minus 4y as it is, but here I have interchanged the position. I have taken minus 9x and I have put plus 6 in the last. Now now what you call pair them. So if you pair 6xy minus 4y and minus 9x plus 6, in this the HCF of 6 and 4 is 2, the HCF of x is xy and y is y, and remaining 3x minus 2 in the bracket. Multiply it and check. 2 into 3 is 6, x into y is xy, plus into minus is minus, 2 into 2 is 4, 4y. Now in this 3 is common, that is the HCF of 9 and 6 is 3, take 3 outside and remaining you put in the bracket. Minus into plus is minus, 3 into 3 is 9x, minus into minus is plus, and 3 into 2 is 6. Remember, when we factorize, when we multiply, we should get back the previous step. Then only our method of factorization is correct. Now again take HCF here, so 3x minus 2 is common, take 3x minus 2 outside and 2y minus 3 in the bracket, and that is what is the factorization of the given algebraic expression. We have expressed it as the product of two algebraic expressions here. So the method is very simple. First try grouping it, but if you fail to group it to get factorization done, then regroup it, take HCF common, again take HCF common. So these are the 4 steps which we have to follow in this method. Now the next important method is the identity method. Now let us consider an example here. Say the word that it's very clear we have to use an identity here. We have got the example here is x square minus 81. X square minus 81 can be written as x square minus 9 square. And you know that it is a square minus b square. We have an identity, a square minus b square is a plus b into a minus b, where a is x and b is 9. So we have got a square minus b square, that is x square minus 9 square, and apply the right side. So it will be x plus a and x minus b. X is x, and that is a is x here and b is 9. Therefore x plus 9 into x plus x minus 9, x plus 9 into x minus 9. So that is what is the identity method. Now let us take one more example. Now we have got an algebraic expression of 3 terms here, 4x square plus 20xy plus 25y square. Now by inspection we see that the first term is the square term, 4x square becomes 2x whole raised to square, 25y square is 5y whole raised to square. That means first term and the last term are square terms. So we have to check whether we can apply the identity here. The identity which can be applied is a square and b square is there. So a square b square is there, and the middle term is 2ab. If I use this identity, then I will get a plus b whole raised to square. But now we have to confirm whether the middle term is possible here. Now we know that 2x is the first term, 5y is the second, next is the last term. When I multiply 2x and 5y with 2, it will be 2 into 2x into 5y, that is 2 into 4, 4 into 5 is 20xy. 100% we get the middle term. Therefore I can use this identity. Now let us rearrange these terms here. 4x square is 2x square, 20xy is 2 into 2x 5y, 25 square is 5y square. So it is a square plus 2ab plus b square form. Now I can apply this identity, take a plus b. A is 2x, b is 5y, therefore it is 2x plus 5y whole raised to square, and therefore the factorization is 2x plus 5y into 2x plus 5y. Again we have expressed the given algebraic expression as the product of two algebraic expression, and here we have used the identity a square plus 2ab plus b square is equal to a plus b whole raised to square. Remember that. Now one more example, 27x cube minus 216x square plus 576x minus 512. Now looks very difficult here, but see, this is the cube term. 27x cube is 3x cube, 512 is 8 cube. So we have two cubes here, terms here, first and the last. Now if two cube terms are there, we can definitely apply one of the identities, that is a cube minus 3a square plus 3ab square minus b cube is a minus b whole raised to cube. Now we have to check whether the middle two terms can be obtained there correctly. If the middle terms are exactly the way it is, then we can use this identity. So let us understand. 27x cube is 3x whole raised to cube minus and this is minus 8 cube, then this is minus 3a square b. A is 3x square into b is 8, and 3ab square plus 3a is 3x and b is 8 square. Now multiply. Minus 3 into 3 is minus 9, into 8 is minus 216, and therefore it is 100%. So 3 square is 9, 9 into 3 27, 27 into 8 is 216, and that is correct, and x square. That means we got the term. Now same way you can check here. 3 into 3 is 9, 8 square is 64, 64 into 9 is 576 into x, and the next term is 512 as it is 8 cube. That means it is exactly this identity. Now therefore RHS is a minus b whole raised to cube. Use this. Therefore here we have a as 3x and b is equal to 8. Therefore a minus b whole raised to cube becomes 3x minus 8 whole raised to cube, and 3x minus 8 whole raised to cube is 3x minus 8, 3x minus 8 and 3x minus 8, and that is what is the factorization. So we have three important factors here, because it is third degree what you call algebraic expression or polynomial. So therefore remember, if it is second degree we have 2 factors, if it is third degree we have 3 factors. Now the next important method is the middle term splitting method of factorization. Now let us understand this, and as I've told you, in middle term splitting method we use an identity x plus a into x plus b is equal to x square plus a plus b into x plus ab. Let us see how it is used. Now this is the example given here, x square plus 15x plus 50. Now there are only 3 terms here. So therefore whenever there are 3 terms we have to go for middle term splitting. So 15x is the middle term, we have to split it and make 4 terms. But there is a procedure of splitting, and the procedure is very simple. Check the coefficient of x square first, it is 1. Multiply the constant is 50. Multiply the coefficient of x square and the constant, that is 1 into 50 is 50. Now find 2 numbers a and b, so that the multiplication, when you multiply you get 50, and when you add you get 15, and the 2 numbers are 10 into 5 is 50, 10 plus 5 is 15. So therefore we can split it in the form x square plus 10x plus 5x plus 50. Now we have got 4 terms here, and when 4 terms are there we can very well go for grouping and taking HCF common. So now group it. So first pair is grouped, second pair is grouped. Now the HCF between x square plus 10x is x. Take x outside, x into x is x square, and x into 10 is 10x. Therefore in the bracket we get x plus 10. Here 5 is common, take 5 outside, 5 into x, therefore x will come here. 5 into 10 is 50, 10 will come in the bracket. So we have got x in the bracket, x plus 10 plus 5 in the bracket, x plus 10. Now x plus 10 is common, take x plus 10 outside and put in the bracket x plus 5. So that is the method of what we call middle term splitting method. So please remember this method, practice it and learn. Okay, now let us go for one more example. 3x square minus 10x plus 8. This is a algebraic expression here. Now we have 3 terms here. Now we have to go for middle term splitting method. Now the method is, what is the coefficient of x square here? 3. What is the constant here? Plus 8. So 8 into 3 is 24. We have got 24. Now find 2 numbers a and b. When we multiply we get 24, and when we add we get the middle term, that is coefficient, that is minus 10. And the numbers are a is equal to minus x, b is equal to minus 4, because minus 6 into minus 4 becomes 24, minus 6, and when we add to minus 4 it becomes minus 10. Therefore split it such so that we can split in the middle term as 3x square minus 6x minus 4x plus 8. Now please remember, minus 6 minus 4 is minus 10, minus into minus is plus, and 6 into 4 is 24, because 8 into 3 is 24, and we have now 4 terms here. Now go for grouping and taking HCF common. So group the first 2 terms and the last 2 terms. Now take the common thing here. 3x is common, because 3x into x is 3x square, minus as it is 3x into 2 becomes 6x, and this is the correct taking common. Now minus 4x plus 8, what is common here? 4. Take 4 outside and put x in the bracket, and then minus 2 in the bracket. So minus 4 into x becomes minus 4x, minus into minus is plus, and 4 into 2 is 8. And now take common here. The common is x minus 2. Take x minus 2 common and put 3x minus 4 in the bracket, and that is what is the method of middle term. Okay, middle term splitting method. Now the important procedure is grouping and taking. So again you see here, although it is a middle term splitting method, again we end with grouping and taking HCF common, or taking HCF common, which is the basics of factorization of algebraic expressions. Now there are different applications of what you call the factorization. So let us see how we can use it. Now this is here we have an example where we have to simplify. It looks so difficult first. That is 116 into 116 into 116 plus 34 into 34 into 34 divided by 116 into 116 minus 116 into 34 plus 34 into 34. Looks very, very difficult. So now let us make it so it is simple. The calculations are going to be very easy if we apply the identities and factorization method. Now let us take 116 as a and 34 as b. Now replace 116 here, it becomes a cube, and this becomes b cube, and here it becomes a square minus ab plus b square, a square minus ab plus b square. We know that the identity we have a cube plus b cube, and a cube plus b cube identity is a plus b in the bracket, a square minus ab plus b square, and a square minus ab plus b square. You see, a square minus ab plus b square and a square minus ab plus b square will cancel, and what we get is a plus b. And what is a? 116, and what is b? 34. Put the values, add it, we get 150. So therefore simplification of such a huge number, huge fraction of different numbers made it is so very simple now, and we get the answer as 150. Otherwise multiplying these three and then multiplying all the other values, what you call simplification, would have been a very tedious task. Now here it has become simple by using factorization and identities. So that is how we can use the identities and factorization in calculations.